Good morning. I'm Padmapriya, Assistant Professor in the Department of CSE in RMD Engineering College. Today, we are going to see the topic Breadth Frist Search under the subject Data Structures. Breadth Frist Search. It is an algorithm in a data structure, which is a graph traversal algorithm that starts traversing the graph from the root node and explores all the neighboring nodes. While using the BFS for traversal, any node in the graph can be considered as the root node. We use a queue data structure to implement the BFS traversal. Now let us see the algorithm. Step 1. So first, we have to define a queue of size, total number of vertices in the graph. The second step is to select any vertex as a starting point for traversal. Visit that vertex and insert it into the queue. Now, third step, visit all the non-visited adjacent vertices of the vertex, which is at the front of the queue, and insert them into the queue. When there is no new vertex to be visited from the vertex, which is at the front of the queue, then delete that vertex. Repeat the steps 3 and 4 until queue becomes empty. When queue becomes empty, then produce the final spanning tree by removing unused edges from the graph. Now let us consider the following example graph to perform the BFS traversal. First, we have to select the vertex A as a starting point. Now, insert the vertex A into the queue. Now, we have to check all the adjacent vertices of the vertex A. That is B, E, and D. These are the adjacent vertices of A and which are not visited. So, we are going to insert all these new visited vertices, that is B, E, and D, into the queue. Now, we have to check if there are any more vertex which is non-visited from A. No. So, all the vertex which is from A is being visited, that is B, E, D. Now, we have to remove the vertex A from the queue. Now, the same process have to be repeated for all the other vertices now. Now, the vertex D, we have to check, is there any other unvisited vertex? No. So, from D, A, and E, which is already been visited. So, we have to delete the vertex D from the queue. Now, for E. So, for E, what are the unvisited vertex from E? It is going to be E, from E, D, A, B, C, and F. So, D, A is already been visited and we have removed it from the queue. B is already been visited and is there in the queue. Now, C and F, we have to add it into the queue. So, we are going to add the vertex C and F by visiting them and we are going to add it to the queue. After visiting that, we have to remove the vertex E from the queue. Next, we have to check from B. So, from B, the adjacent vertices are A, E, C, F. A, E, C. So, all these nodes have been visited. So, we have to remove the B from the queue. From C, we have to check what are the adjacent vertices. So, from C, F, E, B, and G. So, B, E, F is already been visited. So, G is going to be inserted into the queue. And we are going to remove the C from the queue. And we are going to check for F. So, for F, C, E, and G. So, these are the vertexes. So, E, C is already been visited and G is also already been visited. So, we are going to remove the F from the queue. And the last node is going to be, vertex is going to be G. And we are going to delete G also from the queue. So, now the queue has become empty. So, we are going to stop the BFS process. So, the final result of the BFS is the spanning tree as been shown below. So, first A, from A, B, E, D, and from E, C, and F, and from C, G. So, this is the final spanning tree. Now, let us see the program for it. So, the BFS program starts with initializing a queue and we are going to visit a vertex. So, let U be the vertex and we are going to visit it. So, it is going to be initialized as 1. So, now we are going to enqueue the vertex and we are going to insert those vertices into the queue. So, if the queue is not going to be empty, what is going to happen? So each vertex is going to be dequeued from the queue and we are going to print it for the output. Now for all the vertices which is adjacent to that vertex, we are going to check if the visited vertex, if it is going to be 0 means we are going to enqueue it and it is going to be shown as visited. If it has not been visited, we are going to add it to the queue. So this is the program for the Breadth Frist Search traversal. Thank you.